Hello guys, welcome to Maths with Edu Kartik, and today we are going to start with a new chapter, which is chapter number 6, Triangles. And this is our introduction video for that chapter. See, before starting any chapter, we must know what we are going to study in that chapter. So, in this video, we are going to study about triangles. And see, in class ninth, we have read about the congruence of triangles, means how a triangle equal to each other. We read 5 criterias, but here we are going to learn about similarity of triangle. Now there is a difference between a triangle similar and a triangle is congruent. There is a difference between them. But before doing this, firstly we'll start. Here, first one is core foundations. See, similarity versus congruence. What is the difference between a triangle, two triangles which are similar and two triangles which are congruent? Not only triangles, but any figure can be congruent, or you can say it can be similar. See, firstly, I'll take these two triangles. See, this one is a big one. Wait, let's take something else. Yes. Now see, these two triangles are same as each other, same shape, but this one is bigger, this one is smaller. If you take an example of square, this is a big square and this is a small square. See, these angles are equal. These angles of these triangles. This angle of this triangle, this angle of this triangle, and this angle of these both triangles are equal to each other. Then these are similar. See, this is 90, this 90, this 90, and all these angles are 90. These angles are equal to each other. These are similar figures. But what's the difference? They are not necessarily equal to each other. See, if I take this, let's remove these. If I take this is a square and I take this one. These both squares are equal to each other in size. So they will be congruent. See, similarity is shown by this symbol and congruence is shown by this symbol. If two figures are congruent, they are surely similar to each other. But if a figure is similar, if two figures are similar to each other, they are not necessarily congruent to each other. Okay? Now see, shapes that look the same but they are scaled to different sizes means shape is same but the size is different. For any two polygons to be considered as similar, all corresponding angles must be equal. See, all angles must be equal to each other and all corresponding sides must share the exact same ratio. The ratio of the sides means ratio of this side to if I take this one is big and this one is small. The ratio of this side to this side, this side to this side, this side to this, and this to this side must be same to say that these two figures are congruent. No, these two figures are similar to each other. Here congruent figures, shape that are identical in both shape and actual size. It means that, for example, I have a triangle and another triangle. These two triangles are congruent. So if I take one triangle and put it on the other, so you will see only one triangle. Why? Because the other triangle is getting overlapped by the second triangle and you cannot see the second triangle. Okay, it is covering the second triangle exactly. For any two polygons to be considered congruent, all corresponding angles must be equal. See, all angles must be equal. This is a common criteria. And all corresponding sides must be equal. Here the ratios of sides was equal and here the sides are equal. I hope you have understood the difference between congruence and that similarity. You have known the signs also. This is for the similarity and this is for the congruence. Just add equal to this and this will become congruence sign. Thales theorem, also known as BPT theorem, or you can say by proportionality. Proportionality theorem. By proportionality theorem, also known as BPT theorem and also known as Thales theorem. It means that if a line is drawn parallel to one side of a triangle, means see, wait, this is our triangle. Here if we draw a line parallel, this line is parallel to this line. So it says that to intersect each other on the two sides, means this line is intersecting the two other sides on two distinct points. Then other two sides are divided in the exact same ratio. Means if this is A, B, C, this line is PQ. Then it says that this side upon this side will be equal to this side upon this side, or it can be this side upon this side is equal to this side upon this side, or it also can be this side upon this side is equal to this side upon this side. There are totally 6 things you can make: small upon large, or you can say large upon small. Then here also will be equal to small upon large. But see, one thing must be common. If you are taking small one upon the larger one, then this side also you will have to take small one upon the larger one. Means if you take AP upon AB, so you will have to take AQ upon AC. Means the sides, ratio of the sides will be equal, and it will be equal only when you take the correct sides. If a triangle, if this was a triangle, wait, yes, if it was a triangle DE, ABCDE, this was line DE and triangle was ABC, then it is shown that AD upon DB will be equal to AE upon EC, means this side upon this side equal to this side upon this side. I hope this is clear. Now, this was our Thales theorem. This is the most important theorem in our whole chapter and it will be continued till the end. Now, criteria for similarity. How can you say that two triangles ABC and triangle PQR are similar triangles? How can you say this? A criterion. If two triangles correspond corresponding angles are equal, then their corresponding sides are in the same ratio and triangles are similar. See, instead of AAA, you can also use AA, because if two angles are same, then the third angle will automatically be same. So you can write both AA similarity or AAA similarity. See here, if these two angles or these two angles or these two angles are similar to these two or these two angles, then these triangles are equal to each other. Okay. Second is SSS criterion. For the corresponding sides of two triangles are proportional, then their corresponding angles are equal. Okay. If the corresponding sides means all the sides of three triangles are equal, means this side is equal to this and this side, then these triangles are similar. SSS criterion. But remember, if a thing is congruent, then it is similar. But if a thing is similar, then it is not congruent. Okay? Means you can that you can understand it by this way. See, humans are living things, but all living things are not human. Okay? Because some part of living things are human, and in living things animals also come, birds also come. Okay, this was our example, and the third one is SAS criterion. If one angle and two sides of a triangle is equal to the other corresponding sides and angles of a triangle, then congratulations, you have got two triangles similar by using SS criterion. I hope this is clear. And now here comes areas of similar triangles. See, it says that the ratio of the areas of two similar triangles. Ratio of the areas of two similar triangles. For example, triangle ABC and triangle PQR. If ratios of two similar triangles, if these two triangles are similar, then ratio of triangle ABC's area upon area of triangle PQR will be equal to the square, the ratio of the square of any two corresponding sides. If I say AB upon PQ, BC upon QR, or AC upon PR, anyone, I'll say AB upon PQ. AB upon PQ. Square, square. Ratio of the squares of the sides will be equal. Now, the Pythagoras theorem. We have read this since our class 6th. Since when the algebra has started, means the thing x is coming in the mathematics, means our class 6th. From then, we have been learning this theorem, Pythagoras theorem, which says that if there is a triangle, specifically right angle triangle ABC, then this is hypotenuse, this is perpendicular, and this is base perpendicular and hypotenuse. Then the square of hypotenuse will be equal to the sum of squares of base and perpendicular. Means h square equals to b square plus p square. It means that AB square plus BC square will be equal to AC square. Okay. Now, how do you identify hypotenuse? The largest side by seeing, or you can say the side just in front of the right angle is our hypotenuse. Now coming here, real world applications of this. So height estimations using similarity and shadow lengths, you can actually accurately measure the tall structures like buildings, towers, or pyramids. Pyramids, they are also of triangular shape. Triangulation and GPS, mapping terrains, tracking nautical locations, and designing advanced global positioning systems using geometric models. Next is structural rigidity. Triangular frames distribute weight more evenly than quadrilaterals. Means if the frames are triangles, then the weight is distributed in more even form than any other quadrilateral or any other structure. Now, geometry through history. First were Thales, who gave us BPT theorem, or you can say Thales theorem. Next is Pythagoras, who came and gave us Pythagoras theorem. Now Euclid, you have read about Euclid in our class 9th. He gave many postulates and axioms. Now modern era, present day forms the basis of modern computer rendering and CGI. Okay, now at last what we always do, questions. Let's start. Here our question is find length of AD by using Thales theorem. If DE parallel to BC means DE is parallel to BC, and here we have to find out the length of AD. See, the measurements are, I remember the measurements. This is 1.8, this is 5.4, sorry, 4, 7.2, and AD we don't know. We have to find out the length. Now see, you can do this upon this equal to this upon this, or you can do this upon whole equal to this upon whole, but the lengths of these parts are given, so why would we use a longer method, firstly adding them then dividing them? Instead just divide this upon this and this upon this. So we will have to write by using BPT theorem. By using BPT theorem, 1.8 upon 5.4 equals to AD upon 7.2. This dot is removed, 18 3s are 54. So 7.2 by 3 equal to AD. Remove this into 10, 24 this way, so dot will come here, means AD is equal to 2.4 centimeters. This is our answer. Right now we get easier questions, but as soon as the chapter goes on, the questions becomes harder and harder. This is a very confusing chapter if you don't understand it, but if you understand it, you'll get to know it is a very easy chapter. I hope you liked the video. This was our introductory video, and in the next video we'll start with the NCRT exercise of this chapter. Till then, bye bye.